Okay, good evening, guys. Welcome to the time series session. So, just let me know I'm clearly visible and audible, guys. Yes, good evening. I'm clearly visible, guys, and audible. Okay, okay. Thanks for the confirmation. Okay, thank you, thank you, thank you. Good evening, thank you. Okay, so we can start now. Okay, still there are some folks who are joining right now. So we'll wait for 1 minute to start. Before that, I'll give a brief introduction about the today's session. In today's session, we are going to cover the what is a time series. Okay, right now the maximum the projects are from time series. So where they are getting a data with respect to time. Okay, so today we'll see the brief introduction about the time series and its analysis and forecasting. Okay. Okay, yeah. What is the job market? Why is it little bit low? Okay, I thought. Hello, it's yeah. I'm audible or not? Okay, now it's fine. Yes, I think now it's clear. Correct. Good evening to all. I'm audible, guys. Just give me a thumbs up. Yeah, in chat box. So time series is for one dimensional only. Yes, 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 yes. We'll see that one also. Okay. Okay, fine. I think we can good to go. Fine. So guys, so without wasting time, I'll share my screen. Just let me know once it's visible. Yeah. So we have a two notebook. Okay. This notebook I've created. Okay, and we'll explain one by one. So I thought this is a best notebook for you. Okay, when I was practicing the time series data, so at that time I gone through the various books, various the videos, and even there's some articles on Medium. Right now I'm also working on a similar kind of project, so where I'm using the different time scale data. So we are some forecasting data depends on the time. So first of all, we'll see the basic difference between the traditional machine learning algorithm or the ML algorithm, which is like we're going to learn in offline classes. It's like the linear regression, logistic regression, and what is exactly difference between those algorithms and time series analysis. Okay, because it's also one of the area where a maximum projects right now they are working on the various parameter like time, seasonality, then trends. Okay, so we'll see that one also, because a maximum time these are the keywords. I know it's a new for you, but definitely we'll go through one by one. Okay, so first of all, we'll start from what is exactly time series, and then we'll see the what is analysis, what is the AR model, what is the I stands for, then MA. So yeah, and at the end of this session, we'll see one algorithm that is we are already I have already implemented. So I'll go through like one by one. So I'll try to explain how the time series model implemented. So we'll see the ARIMA. Okay, and uh, in coming future, like in offline classes, I'll start one series, so that will cover the ARIMA model, AR model, MA model, along with this SARIMA model, that is a seasonal ARIMA. Okay, so I know this is a little bit tricky, these words tricky for you, but no worry, we'll go through one by one. Okay, can we start? Yes, guys, can we start just with the confirmation? Okay, so guys, before this session, I'll just give the brief information about this, because this is a little bit tricky. This concept is little bit tricky because uh, most of the words are new, and even we don't know about the actual data sets. Okay, because maximum time when we get the data in the form of tables. Okay, so in that case it is very easy to segregate the independent column and dependent column, correct? But in case of time series data, so we have the index data which is on time. Okay, so first of all we'll see what is exactly the time series. Okay, so guys, in traditional way, so where when we implement the machine learning algorithm in, so we have some independent features and some dependent features, independent features, and we have some dependent feature, correct? So here this dependent feature is depend on this independent feature, this straightforward concept. But in terms of time, okay, so the time feature, this is time constraint, or we can say this time is a dependent for you. Suppose we have like the feature like sales. Okay, so time, with respect to time we need to analyze the sales, because the sale is completely depend on time. Okay, so it's a completely different dimension data. Here we have a different data set, different the features, correct? So we can easily find out the correlation between the dependent and independent feature using the Pearson correlation formula, or there are other metrics, okay, using heat map. But in case of time series, there are some components, okay, we need to consider while taking the difference or taking the inference, because this data completely depend on time. Okay, for example, stock market, stock market data. Okay, even for suppose like grocery shop data. Okay, so we have suppose 1 year data. Okay, we have 1 year data, and in 1 year suppose we can say suppose a Jan month. Okay, in Jan month and to December month, so we have the maximum sale around the November, October, around December, correct? So that means this is a seasonal data. So these are the main challenges that we are getting while exploring the this type of data set. Okay, seasonality, unpredictability, then trends. Okay, then we can say uh, different patterns, noise, correct? So these are, we can say, sorry, just a minute, guys. Yeah, I think, sir, can you please increase the volume from your side? Really, guys, I don't know. I think there are some folks who are not able to listen properly. Yes, I'm okay. I'll try to wear the earphone. Just a minute. I thought, yeah, now it's fine. Yes, guys, it's fine. Yes, guys. Okay, try to increase the volume. Thought, I think it's a perfectly fine. I don't think any issue. Okay, voice is perfect. Fine, fine. So if any disturbance is there, so please kindly check at your side. Okay, fine. So basic difference is what? So we have a different data set. For example, we can take the stock market data. So suppose in like today, or even suppose in like before 8 days. Okay, suppose on 8th of, like for example 8th of like April, we have like one stock, we have one stock like Tata, okay, Tata Capital, like suppose Tata Insurance or something. So we have suppose 250 price, okay, and on 9th of April, on 9th of April, we have suppose 300. On 10th of April, suppose we have around suppose 250, okay, and 11th it's around suppose again 380. So the data changes over the with respect to time, correct? So in traditional way, so this data is not changed frequently, but here we have the frequent change, okay. So that means we have, there are like we have so the components we need to take into the consideration while analysis of time series data. So the first component is seasonality, okay. So we know that like we have suppose sub season like some like for AC sale, okay, suppose AC sale. So the maximum AC sale in the month or in summer season, correct? So that means this sale is completely depend on season, correct? So we have like this type of data also, that means which is completely on season, okay. Sometimes trends, okay, sometimes we need to consider the trends, some like sometimes we get the data in like there are some festivals, or we can say there are some different parameter we can like that raise to the trends, that depends on the trends, correct? So season, trends. Next, these are the main component of time series while exploring the data. Okay, when we have a data, so always guys we have data in terms of date or year or time. It may be anything, date, year or time. Okay, and we have a dependent feature like independent features, like suppose sales, with respect to sales, correct? So here we have a date, year or time, and we have a sales. So this sales completely depend on date or time. So first we need to analyze the data with respect to, is there any seasonality in your data set, that we need to find out first of all, okay. Is there any trends, is there any trends in your data set, okay. Yeah, how to find out, we'll see, okay. But yeah, so there are some parameter like season, trends, or some noise also there, okay. For example, I'll just try to explain with the help of this pen. Suppose for example, suppose we have this data, suppose this one, like this one, okay, and the same pattern we can find out here, okay. So you can see here the same pattern we're getting, and here we have this this pattern also, correct? So this pattern is nothing but we can say it's a season, because you can see after some period of time we get the same pattern. Here also after some period of time we get the same pattern. So this is nothing but the season, okay. Sometimes we may get the noise, okay. Okay, before that we have trends. Sometimes, for example, we can take the medical history like COVID-19 data, and with respect to the paracetamol sales, okay. So we can find this the trend like this one, correct? So we have two types of trends, okay. One is uptrend, the another is a downtrend, like this one, correct? So this complete data, it depends on the time, obviously, because we can say in 2019 or 20, 21, 22, the sales of paracetamol tablets, it's drastically changes, like that drastically increases. So that means this sales completely depend on this particular year, correct, the time frame. But we can't say it's a season, because it's not seasonal, right? Because this sale is completely depend on time, and at that time there is a like outbreak. So because of that, this trends occurs, correct? So this the main challenges while analyzing the data. The first one is seasonality, the second one is trend, correct? After that, we may get the drastic change, or we can say unpredictable changes. Okay, sometimes maybe because of some events. For example, if you take the example of like IPL. Okay, during the IPL, suppose the final match, on a final match, the sale of ticket drastically change. It's unpredictable. We can't predict the actual sales, so we can say it's unpredictable data. That again, that depends on the space, the time, again the venue, but we get the uh, a sudden change, correct? So it's a unpredictable change. This is one of a challenge. Next, yes, a noise data. Okay, for example, suppose we get the data in the form like this one. Okay, so this one is the time. Okay, and this one the like cell. So we can say like this one, like this one, and this one, like this one. So this pattern is nothing but the noise. This pattern is nothing but the noise, correct? So this is the one of the challenge. That means how many challenges we have seen right now while analyzing this time series data? Yes, first, yes guys, first seasonality, then yes, second one trends, second one trends, third one unpredictable change, fourth one noise, correct? Is there any issue guys? Yes, seasonality, trends, noise, and unpredictable change or drastic change. Okay, yes, got it guys? Up to this, any issue? The challenges while what? Analyzing the time series data. So first of all, guys, please tell me, have got the clear cut idea about the what is exactly time series data, or how do we are analyzing this time series analysis? That means this data. Yes, I don't know. It's yes. Okay. So in traditional machine learning algorithm, you can easily find out the independent and dependent feature. That is not issue. But in terms of the time series data, we have the lots of challenges. Okay. Okay. Have you got obviously guys, this is not possible to explain complete time series in 1 or 2 hours. Okay, because it's completely new field of machine learning. Because when we talk about the deep learning, so we have a different like algorithm based on the data. Suppose for example, CNN, convolutional neural network, it's completely on image processing, correct? RNN, it's a recurrent neural network, it's completely on, yes, time series data. And ANN, artificial neural network, it's completely on regression type data. Okay, the same thing we can implement using deep learning also. Okay, recurrent neural network, so where we have a trends. Okay, fine. Suppose we get the data, and we need to find out the trends. Oh, sorry, we need to find out the forecasting, correct? So first task, okay, in time series analysis, to make the curves smoothen. Okay, the first task here, what we need to do, suppose we have a pattern, correct? Suppose this is the pattern, correct? This is the pattern, this is the pattern with respect to time. And if you want to predict a future pattern, this pattern, okay, maybe it may be like this one, or it may be like this one. So how we can predict, how we can forecast? What is mean by forecasting? First of all, what is mean by forecasting? Yes, forecasting means what? It's the future prediction based on the past data. Correct? I have presentation, but yeah, but I don't want to bore, so that's why I bore you. Okay, you can see. What is a time series? First of all, just I'll just read. Okay, a time series is a set of observation on quantitative variable collected over a time. Very simple. Okay, we have a data set, we have a data points based on the times. Okay, example, historical data on sales, inventory, customer counts, interest rate and cost. Okay, so in our current project, we need to predict the number of counts. Okay, how many, like, uh, I can't disclose, but yeah, this how many entities will be in on that particular day. Okay, based on the historical data, based on the historical patterns. Correct? So obviously, so maximum businesses, maximum organizations, they are interested for forecasting on time variable. Okay, so often independent variables are not available, obviously, to build a regression model on time series variable. Okay, then the time series analysis, we analyze the past behavior of variable in order to predict the future, obviously, because we need to analyze the past behavior, how the patterns are there, how the patterns are related to the time. So the same pattern we can predict on current time frame. Very easy. Okay, so that means we need to like capture the trend or capture the pattern. Okay, and basically, suppose I'll give the one example, very simple example. Okay, suppose here, on sales example. Okay, sales example, and here suppose 2020. Okay, and here 2021, 2022, 2023. Okay, and 2024, 2025. Okay, in 2020 we have 450 millions of, like million, or the sale. Okay, in 2021 it's around 500. In 2022 it's around 600. In 2023 it's around like 590. In 2024 we have, like, around, it's a 390. So what would be the future sale of 25? So as a layman term, what will be the future of, like, future sale of 25? How we can find out? In just a layman term. Use just a layman term. Yes. How we can find out for this one, for these values? I need to find out this sale. So which value will be there as a layman term? I don't want the exact technical term over there. As a layman term, what should be the value in place of 2025? Yes. Yes, guys. What will be the value for the sale in 2024? Close to previous value. Okay. Okay. Average value. Exact. Okay. So as a layman term, we can take a average. Just an average. Okay. You can take an average. Yeah. You can predict. Yeah. This is the predicted value. The same thing happen in a time series. Okay. Just the terms are different. Like lag. Here is a one term, that is a lag. Lagging means what? You can take the average of previous 2 lag. You can take the average of previous 3 lag. You can take the average of previous 4 lag. Okay, and this lag we can call as a window, time frame window. Suppose we have a 10-year data. Okay, so you can take the 12 month as a window. Okay, as a window size. So we can take the average. Okay, the same model, the same thing we can implement here also. Okay, so we can take the previous average, like this one, like this one, like this one, this pattern average, and the same pattern we can predict for this one, just an average pattern. We have not done anything, just we have taken the average. So we have two types of average again. Auto regressive, usko, that is a AR, and one is moving average. Moving average means what? Yes, we have taken this one. What is the average of this one? Suppose for example this average is what, like it's a how much? Suppose 450 plus 500, correct? It divided by how much? It's a what, divided by 2. It's again how much, guys? Is divided by 2. It's a 475, correct? Now the average of this one, previous one, this one, now average of this one, again this average of this one, like this one. It's a moving average, it's called as a moving average. We have taken the average, then the same value we can take for the next, the same whatever the value will become, that will again we'll take the addition, we take the average, again this one. So every time we are taking moving average. So here two terminology are very important. One is what, auto regressive, and another is moving average. Okay, and the one terminology that is a I, it's a difference actually, it's a difference of the AR and MA. So moving average, don't worry, uh, we'll see this complete concept during the offline session, because I've already included this time series concept in a machine learning and AI batches, for AI batches. Okay, because it's a like sometimes you may get the allocation on time series project. Okay, so in that case you should know how to implement time series machine learning model, because it's completely different from the regular machine learning model. Okay, here we don't have any other features. Here we have only two features. One is the time, other one the actual features. So based on that, we need to predict the future sales or future forecasting. Got it? So this AR means auto regressive, MA means moving average, and this I means difference. Okay, and this combinedly we can call it as a ARIMA model. It's a auto regressive, it's a integrated moving average. Okay, so this model we are going to, yeah, there are some other model also there. It's a SARIMA models also there. Okay, this is completely on seasonal. So suppose we have a seasonal data, so in that case if you take the average, then it will be deviated from actual means. Okay, so first of all, so first task, when we get the data, okay, first smoothen the curve. Means what? Suppose we have like data set like this one. Okay, so the first task is to smoothen the curve. Okay, that means it's a completely non-stationary data. Okay, so we need to convert into stationary data. There are some test which is adaptive Dickey Fuller test. Okay, that test we can like take the for finding the p value, then other parameters. So we can take that p value for the just checking whether this is the stationary data or non-stationary data. Okay, if non-stationary data, we need to convert into a stationary data, then and then we can implement the, because when we get this type of data, it's having the different mean, correct? Suppose this we can take this mean, so this completely different mean, it's having different mean, this having the different mean, and even a variance. So we need to minimize the first, we need to constant, make the constant mean, variance, these two parameter we need to like smoothen means what, we need to adjust this two parameter on constant side, it should not be changed drastically. So here we'll take like this one, this is the main parameter. Okay, This is the idea behind the time series model or time series analysis. When we get the data, first we need to check the component, okay, whether this data are having the seasonal or any trend or any unpredictable changes or any even we have a cycles, okay, cyclic change. Cyclic change means what? Like this one, okay, cyclic change. So in that case, yes, we need to again convert into smoothen curve, okay. So that is the biggest challenge to while data pre-processing, okay, because when we got the data, so first we need to check the mean and its variance, how the mean deviated from the rest of. Suppose we take the mean of this pattern, okay, so this pattern mean and again this pattern mean is completely deviated because of this height or this magnitude, correct. Again for this one also we got the mean, different mean, and for again different mean. So we need to constant this mean value and variance, we need to minimize this mean and variance, then we can predict. Otherwise if your data is containing the high variance data, okay, or having the high variance, then we can't predict. Even if we predict, the actual values and predicted values is like too far from each other. So that means at the end we get the low accuracy. Okay, so first we need to smooth the curve. That means we need to convert this non-stationary data into stationary. Okay, so without wasting time, first I'll explain this one. So here regression analysis, okay, then it's a statistical technique, okay, where that is explaining the past or forecasting future events, the prediction in function time, days, month and year we already discussed. Okay, no casual variable, okay, because it's only contain the time and actual variable. Yeah, so this is a time frame, how we can predict, how far we can predict, okay, because obviously suppose we have a 10-year data, we can predict 11th year, 12 year, 13 year, that means year wise data we can predict. Okay, so you can see short term 1 to 2 period, medium term 5 to 10 periods, long term 12 plus period, or no line of demarcations. Okay, I don't know its actual meaning, but yeah, trend, it's a gradual. If you have the gradual long term movement up and down of demand, easiest to detect. Yeah, it's very easy to detect the trend. Okay, the component of time series analysis, yes, cycle, we already seen what is that cycle, repetitive movement in demand, seasonal variation, so here up and down, repetitive movement with a trend, that means periodically. Okay, then remove variations, obviously we need to remove the variation. So this is the one sample, so this is a time period, this is a sale in $1,000, you can see time period. Okay, so it's the actual sales actually. The components of, again, difficult to forecast the demand because there is a no casual variables. Obviously the component trend, stability, then cycles, random variation cannot always be easily or accurately identified. This is also one of the challenge while analyzing the time series data. Okay, some time series terms you should know. The first is the stationary data. Okay, with means it's having the already the smooth curve, that means already having the mean and variation on constant side. Okay, so we don't have any significant upward and downward trend over the time, so we can say it's a stationary data. Non-stationary data, the time series variable exhibiting the significant upward and downward trend over time, so we can say it's a non-stationary data. Seasonal data we already seen, it's a some pattern, it's get repeated, so it's a seasonal data. Okay, then there are many different time series technique. Okay, we'll see that one also. These are the mean measuring the accuracy of time series model. So we already see like mean absolute deviation, mean absolute percentage error, square error and root mean square error, the same as a regression model. Okay, yeah, then this extrapolation we don't want that one. Seasonality we know, this is the, we can say the stationary seasonal effects, you can see This is the what? Smoothen the curve. You can see multiple seasonal effects. Okay, you can see. Okay, trends. Okay, yeah, there are some other models like multivariate co-integrations, ARIMA model, SERIMA model, FARIMA model, and GArch. Okay, these are the models right now like we are using in a real-time project. So majorly we are using ARIMA, that is a seasonal ARIMA. Okay, so yeah, so without wasting time, we'll jump into the implementation part. Okay, so we already explained. So ARIMA model having the three different parameter. Okay, one is a P. P is nothing but the lags, or we can say it's a time window. Okay, we can take any time window. Okay, for taking the average. D is the number of row observation. It's a difference. Okay, degree of differencing. And Q is the size of moving average window. Okay, when we take the moving average, so at that time we need to consider some size. So if the peak dq, these are three parameter is like these are the useful parameter we can say in a ARIMA model. So there are some steps we need to follow. So first of all, examine your data. Definitely we need to plot, so we can take the insight, or we can find out the insight, like the data is considering any special patterns or any stationary like behavior. So you can see here we can plot its pattern and irregularities, then clean up any outliers or missing values. Will we already done in the EDA part. Then yes, take the logarithm on series to help this stabilize the strong growth trend. Obviously we need to what, suppress the trends on seasonality. Okay, then decompose your data. Okay, there are different decomposing techniques. Then check the stationarity. Okay, so here is there any series stationary, then we can use ACF. Okay, it's a PCF to determine the what, it's an auto correlation plot, and it's to determine the stationarity actually. So the auto correlation and choosing the model. So we can choose the model ARIMA by examining the ACF and PCF plots and fit the model. So when which model you want to fit, you can go ahead with the ARIMA or Serimax. Okay, and evaluate the iteration, calculate the forecast. So these are the we can say high level steps we need to perform while time series analysis. Fine. So without wasting time, I'll explain the implementation part. So here I've imported the warning iter tools, pandas. Inside pandas, this data time, it is very important because sometimes we may get the data in string format. Okay, even even if it is in a date or a month or year, so we need to convert into data time. Okay, yeah, then read CSV, then autocorrelation mean square error, then seasonal decompose, and is the AD Fuller. This is a it's a DQ Fuller test. Okay, we need to check whether the data is stationary or not. Okay, and here in state models, okay, we have ARIMA model. Okay, and when we can plot the ACF and PCF. Okay, then we have imported the data. So you can see here we have two types of data. Here the actual IBG, it's a sale, and we have a date. It's a month wise intervals, correct? So fine, then just take the info. Yeah, so whether it is an date or time, so you can see here it is in a object, so that means it is in a string format. So first we need to convert into date and time. So here what you can see, pd dot to date and time, df dot date. Okay, and directly assigned to the index. Okay, means what, we have converted into date and time, and the same column we have assigned as a index column. Fine, then drop the old date column. So you can see df index, we have the indexes values like a date. the rename, we have renamed the column, it's a production, and then we just plot the data. So you can see we got the graph. So guys, tell me what is the hidden pattern inside this graph. Yes, is it seasonality or any trend? Yes guys. Yes, what insight you can find from this pattern? Yes, just let me know in chat session. Yes, what is insight in this graph? Is it trend or seasonality or any drastic change, unpredictable change? Obviously correct, it's a upward trends. Oh no, 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 we don't have seasonality. We don't have any seasonality, you can see it's a trend, no? We don't have any seasonality pattern here. It's a upward trend. Okay, yeah, we can say it's a, sometimes you can say in in middle there are some seasons find, yeah we can say, but actually it's having the trends, obviously. Okay, and it's a upward trends, it's a upward trends, correct. So you can see there is a upward trend with a regular fluctuations. Okay, yes. So now decompose data. Obviously if we have seasonality, we have 10, or we have cycle. So we need to decompose, we need to smoothen the curve, correct. So yeah, so you can see here the building block of this time series analysis are seasonality, again the trend and cycle. Okay, then we need to decompose, so we can directly use the ARIMA model for that. So you can see here we have decomposition method. So seasonal decomposition, we have passed the DF model is to additive. So guys, frankly speaking, in this short period of time we can't cover each and everything. Okay, because these are the parameter: additive, predictive, then adaptive, then there are other parameters also there, so we can't take in a single session. And I'll just give the glimpse about the, like, the time series, how the time series data, like how, what is the behavior of time series data, even what is the pattern. Okay, how we can deal with the time series data. So I'll just give the brief idea, but if you want to learn like in depth, so don't worry, we'll take in offline session. Okay, it will take around 7 to 8 days to complete time series like concept, because first we need to study the AR, then MI, MA, then I, then again there are different models. Okay, and then we can like decomposition, Dickey-Fuller test, then we'll find out the like ACF, PCF, correlation matrix. Okay, then hyperparameter tunings in time series data. So for that we need to take the at least 7 to 8 sessions. Okay, so here we can see here we just decompose. So it is the decomposition, is observed, it's a trend, seasonal, seasonal inside that particular trend. So you can see, and it is the residuals. So we are just decomposing. You can see we have to take the multiplicative technique. One is the additive, it's a multiplicative technique. Okay, then we have a seasonality. So we can, you can see the mean series should not be function of time, the variance series should not be function of time, this properly known as a homoscedasticity. Finally the covariance, that means in short we need to adjust means and variance. You can see here the series said to be stationary when its mean, variance, what, and autocovariance are time invariant. That means it should not be changed drastically. Okay, so that's why, yeah. So after that, what happened? We have checked the in data, we have trends. Okay, after that we can use stationarity. For stationarity, first we need to check the like whether it is stationary or not by using this augmented Dickey-Fuller test. Okay, it will use the there are 4 to 5 parameters it will use. The first, yes, we need to check whether it is a null hypothesis or alternate hypothesis. If it is null hypothesis, then if it is failed, it suggests that time series have a unit root, meaning it is a non-stationary. If we reject the null hypothesis, that means we have the non-stationary. Then if we accept the null hypothesis, then it is a stationary, meaning it is a stationary data. Okay, we have the two values here. It comes under the hypothetical testing. Fine. Then we have applied the Dickey-Fuller test. We got the different values. Okay, here we have the p value. We can see here p value 0.990. Okay, so that means p value is greater than 0.05. So we need to accept the alternate hypothesis, and we need to reject. We are reject the null hypothesis. So that means we have stationary data set. Okay, we need to apply Dickey-Fuller test to check whether the data set is what, stationary data or non-stationary data. Okay, then you can find out the differencing. This is the differencing. Then we have find out we take the some data set, the particular distribution around 50 data points. We are just plotted. It's around 50 data points. Then autocorrelation matrices are there. Okay, I already implemented this ARIMA model in my current project. So you can see we got the OLS. This is the OLS graph or OLS matrices. So here we got the different accuracy for model AR1, AR2, AR3. Okay, even we got the some observation model, ARIMA model. Okay, then method, which method we have used, observation, how many observation we have taken, 965. What is the likelihood of this model? Okay, after that, these are the residuals. Okay, and again we have implemented the same model. We applied the what, hyperparameter tuning, where we have adjusted some parameter and check the final accuracy. So you can see here fitting, this is a model actually. You can see model we have built SMF state space Sarima model. So here actual DF, the order, seasonal order, the enforce stationarity and enforce invertibility. After that we got the this matrices. Then we can plot actual residuals and we can forecast. You can see this is the actual the energy production, and this pattern one step ahead forecast. This orange pattern is nothing but the forecast. So that means based upon the historical data, correct, historical pattern, we have predicted this future pattern. This is the future. This one you can see. This pattern is a predicted pattern. Okay, and we have just applied the model accuracy mean square error. So you can see this is the forecasted, this is the actual, this is the forecasted, and error, the square error, mean square error. You can see what is the error of this one. This is the actual for one. This is the production 1/1/2017. We got the production 116 for forecasted, the predicted values. And what is the error? So we got the this double three error because it's in square. So obviously it gets squared. Error gets squared. Okay. So I know it is a little bit difficult, but guys, there are some terminology we need to study first. Then we can implement this model. Okay. So I hope you got the high level idea about what is the time series and how we can predict the what, the future pattern using the different techniques. Any difficulty right now? You got the basic idea behind the, yes, time series. If you guys, you attend the previously you have attended the session, but no one is demanding for the extended session. Like I've taken the LM model session. Okay, I think I've implemented Gemini API, right? But no one is like is eager to learn about the Copilot. Then what? OpenAI. So I've taken one session, but if you are willing to learn about the LLM model, the implementation of the predictive model on different parameter like image processing, on time series, on a recurrent network, on chatbot. Okay, okay. Then you need to subscribe. Okay, it will motivate me for this live session. Yes. Okay, autopilot. Autopilot, co-pilot. There is co-pilot. Okay. We have different model. Got it, guys? If you want to learn more on the time series, then image processing, then natural language processing, then what? On RNN, ANN, and CNN. Which topic you want me to take in next YouTube live session? Yes, just write down in chat section. Yes, guys. Yes, only one candidate is replying. I don't know. I'm audible. So tell about job market. Right now, there are a number of openings for a data science, then for data engineering and data analyst role. NLP definitely. Okay, NLP. Okay, so next session will be on NLP. Okay, and we'll try to keep one complete end-to-end series for NLP. But guys, on deep learning. Okay, NLP, deep learning. Fine. Yeah, got it. So maximum demand on deep learning and NLP side. So definitely we'll take that one also. Yes, you got the basic idea about the time series, or you want me to explain on like low level site that like session on chatbox using its API, LLM. That is a very easy actually. I already taken the one session on this one LLM model. ChatGPT and AI tools. Actually, guys, the ChatGPT is an actual application of LLM model. Okay, so they have their own API. That API we can use for our personal purpose. Okay, that means we can build our own chat box. I already built a chat box actually. In last session, I've already integrated the API on PyCharm. So we can give the any query, it will reply. Maximum NLP. They will take our jobs. No, 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 no. ChatGPT I will not take any jobs. These are the tool we can use for a smart work. Okay, they will not take your job. Don't worry, because ChatGPT and AI, these are the reinforcement technique. That means they need to learn every day. They need to train. Okay, explain time series at deeper level. Okay, definitely I'll take on in offline session. Okay then. Okay, so next YouTube live session will be on NLP. Fine. And if you want the second part or the on deeper side of NLP on YouTube live, then you can just type in chat box. So I'll plan for that to take the, ev- the each and every details regarding the time series and its other component like ARIMA, SARIMA, and okay, guys. I hope you find this session helpful for you. I don't know. Yes, guys. Thank you. Thank you for joining. Yes. Thanks a lot. Thanks a lot for your time. Thank you.